Hello there. Thank you for having me at PlatformCon. My name is Chad Carlson. I manage the DevRel team at PlatformSH, and today I wanted to talk about the environmental costs of DevOps. We're here at PlatformCon, and whether it is that we're building deployment platforms for our customers, or we're developing and maintaining an internal platform for our own businesses just to manage the DevOps of our applications and the products that we eventually deliver. One of the things that I don't know if gets talked about as much as the technical aspect of achieving security and consistency and reliability is this environmental impact factor. And it's something we talk about a lot at PlatformSH, and so that's why I wanted to make it the focus of my talk. So first, let's kick off with a little bit of history. So we have here a little icon of Tim Berners-Lee. And in the 80s, Tim had a problem. He was an independent contractor working at CERN, and things were getting a bit chaotic. At that time, hundreds of scientists were working on 100 different things with lots of equipment, and it was getting difficult to keep track of who was working on which projects and which software was running on each of their systems. And around that time, a group was set up to unify networking across CERN, where protocols were put in place to open up the network that they had for their laboratories to the rest of the world. And with this network that they had inside of CERN, it was used to not just manage the individual projects, but the software and machines that controlled some of these really complicated high-energy experiments that they were doing there. And so we come back to Tim's problem, which was not just dealing with the network that they have there, but also this influx of public traffic. So we get an idea. So could something be built not just to connect the resources within CERN's network for control and coordination, be set up to connect to this wider public global network for anything? Something simple enough that anyone could really build their own server and their own site set up on that kind of server. And so we get this picture. From this station, we get the first web server. With that, we soon get the first command line based web browser and the first website that we see here. And from these really, really simple beginnings in the late 80s, we get a lot of really interesting things happening once we get these initial protocols set up. So this is by no means a full list of all the things that happen, but hopefully it can give you some kind of idea of how we go from limited numbers of servers that are set up in laboratories and universities across the world to establishing a few protocols and a few really basic ideas set up at the beginning of the web that then take us from, in 1993, somewhere around 500 hosts connected to the global internet to 62,000 by 1995, and some of the major events that kind of influence this kind of growth in the number of hosts connected to the network. And so we're really seeing a much larger footprint in servers accepting traffic and serving content on the web. I'd like for you to keep in mind as you're looking at a table like this, as more and more hosts are combined, none of these machines, whether it's the servers that are hosting the website or the mobile devices that are actually accessing these services, all of them have an environmental cost associated with them, either in building the device itself or in the carbon dioxide that it puts off in the day-to-day operation of those devices. I also want you to think in parallel of how development has changed from the early days of the internet to what it is now. So the way we deliver applications has changed considerably, and it largely has been influenced by how costly it was to set up a server in the first place. We start with this really simple idea of this single next machine serving the first website. But as we get more and more demand on individual sites, we start getting the beginnings of this DevOps pipeline, where in the early days, if you have enough funds to set up a production instance of your server, of your website, this is really the first iteration. And as that cost begins to decrease and things become cheaper compute-wise, we then move on a little bit over to this three-tier deployment model. As more people start to be able to afford these computing resources, we can now simultaneously have our production server and our production website, but also staging and development versions of our websites. And as much as this may have given us the ability to ensure that a change and a new feature that we make can be thoroughly tested on staging with as much like production conditions as possible, this is really a replication of the exact same resources that we have on production. And where we are today is we're not even just dealing with this rigid three-tier deployment model as we move more and more into containerization and virtualization. So we have resources that are far cheaper than they've ever been before. And that means spinning up each of these environments. It also means potentially on-demand environments for every single feature that we develop along the way into a staging QA space. That really comes into the zoom out perspective. Like, do we have a good idea of what the carbon footprint of all of our work in the cloud is today? I've included a screenshot here on this slide written in 2018. Estimates between the devices, their production that are actually accessing websites to the servers themselves, and based off of the growth rate that we can kind of see in the number of hosts that have transpired from 1989 to today, is that the degree in which our industry's contribution to the total CO2 output will grow by the year 2040 is about half of the current contribution of the entire aviation industry. So it's a really non-negligible number. And how much do we consider it in either the choices that we give our clients, in the decisions that we make on a day-to-day basis, which I think usually are based off of things like cost, but environmental cost being its own dimension of optimization to take care of things. Taking from the very beginning to where we are now and how much things have changed. The way we tend to think about it at Platform is first in the operations side of where we deploy the applications really makes a difference. The exact same workload, the exact same application could have a factor of 10 difference in the carbon produced, totally depending on the region of the world that server exists in that's doing that work. And so, what grid does that server exist on? Is that grid powered by nuclear energy, coal? The difference between these things can be quite large and can affect the day-to-day business that we do and the environmental cost, when we could know that information and perform a migration or more selectively choose which regions are the actual deployment targets for our websites. How we deploy really makes a difference. We have some ability and I think responsibility to understand things like when servers are set up, especially in virtual machines. Servers tend to be underutilized. Less than 50% and sometimes far less than 50% of their capacity is being used with the compute that's placed on it. And they're also under-optimized. So a given allocated set of resources for a single application may be far more than that application will ever use. But it's a part of the pricing model. It's a part of the increments of blocks that are set up for somebody to set up their application in the first place. Things are oversized. Things are not optimized. It becomes a real call to action, I think, as we're developing these platforms on either side. How much attention do we pay to setting up some sane defaults for the spaces for apps and environments to be deployed, so that we can reduce this number and kind of increase the density as much as possible on these spaces. And alongside that, infrastructure works the same way. I mean, if we take a look at the comparison of PHP 7.4 versus 8.0 and 8.1, for the most part, we're talking about a 30% faster version of PHP. But PHP 7.4 was released in November of 2020, and by February of 2022, there was still a 43% of all PHP website market share still on 7.4. And there are a lot of different consequences for that. You have plenty of versions of frameworks that rely on 7.4 that kind of lock people into 7.4. But there's also a huge number of those kinds of websites that could have made the upgrade to 8.0 or 8.1, and for a million different other reasons that have to do with the way they have their platform set up or their provider. And even now today, 15 months, 43% of the market share was still 7.4. We're another 15 months later, and they still at a strong 22% of sites out there running PHP are on a version that is 30% slower than some of the recent version of PHP, and contributing that much more to the atmosphere as far as the carbon that they produce on the servers that they're on. And so we could think about it clearly can take longer to make this sort of upgrade. And when we develop our platforms, why should we make it easier to do that? I mean, if real back of the napkin math, that if PHP is attributed to almost 70% of all sites, and we take this sort of market share split that we have across the year, if at the beginning of this table in February we were able to flip the switch and get this 43% of sites from 7.4 to 8 or 8.1, that could result from what it was to up to 81 megatons a year of CO2 not being pumped into the atmosphere just by making this major version change. And being able to provide a system like we try to do at our company, where you can quickly make a change in infrastructure and test its consequences so it can actually be promoted quickly, this is what we're trying to facilitate. Because otherwise things hang back on this outdated version, and really not just the performance of your application suffers, but if we're talking 78% of all websites on the internet, distributively, this may be back of the napkin math, but whatever the actual number is, it's not negligible. It's a real impact to the amount of carbon out of the atmosphere from our whole industry. And I tried to do a little comparison of what this 81.5 megatons looks like, because it's just a number for a scratch math calculation to begin with. And as some sort of context, a single car is estimated at putting in about 5 tons of carbon dioxide a year. And so at 81 megatons, that's about 16 million cars, which is the last table that I checked is more than the entire state of California, the number of the cars in the state of California and the emissions of the entire state. So really, we even if we were off by 50%, 20%, whatever it may be, this is a real non-negligible number as far as contributions to our environment. So where are we now? We started from something very, very simple in the early days of the web, and how that's expanded in the last few decades into very cheap, easily disposable units of compute in containers and in servers that are very cheap to get some time and space on across the world. But where that server is located is not created equal. The energy that it's using is not the same from one region to another. And every single one of these environments, every one of these containers, is really contributing a non-negligible amount to the amount of carbon dioxide and the overall impact that we have in the environment. And so we've come a long way, and I think that as we come to a place where we have better insights and can move ourselves to receive better insights and better data into where we're deploying and why, and what we're deploying, and how easy it is to facilitate people to optimize what it is that they're deploying, we really can integrate a different kind of perspective into the way we do business and the way we deploy applications and even our whole platforms by keeping these kind of details in mind. And that's what I have for today. Thank you very, very much for joining me for this talk. You can find my email inside this slide here. And otherwise, again, thanks for having me and have a great rest of your PlatformCon.